The dependence of the world community on non-renewable fossil fuel reserves to maintain quality of life, sustain economic vitality, and to enable the vast transportation network is one of the most challenging problems facing the world today. Dwindling reserves in the face of rapidly increasing demands, combined with the environmental devastation resulting from global warming and acid deposition, demand the development of a sustainable, affordable, and environmentally friendly energy source. Ethanol is such a renewable clean fuel and is mainly produced from the cornstarch in the United States. Ethanol production in the U.S. is expected to grow to over 20 billion gallons by 2025 from the current 4.9 billion gallons. What happens in the fields during planting, fertilizing, and harvesting is just as critical as converting corn into ethanol. But for our discussion, we will only consider what happens once the corn arrives at the plant. Upon arrival at the plant, the corn moisture level is tested, and then the corn with the desired moisture level is dropped into a conveying system, which then delivers it to the hammer mill. The corn passes through a hammer mill, which grinds it into a fine powder called meal. This increases the surface area to volume ratio and thereby allows efficient release of starch from the corn. Shortly after grinding, the first enzymes are added to start the breakdown of the starch to sugar. The meal is mixed with water and alpha amylase, and then passed through the jet cooker where the starch is liquefied. Heat is applied to enhance liquefaction. Jet cooking with a high temperature stage is used, where the temperature is typically between 120 and 150 degrees Celsius. High temperature also eliminates bacterial contamination in down processing. Yeast is added to the saccharified mash to ferment the glucose to ethanol and carbon dioxide. Fermentation is usually operated in a batch mode. The mash stays in the fermenter for about 48 hours for completion of fermentation. The mash exiting from the cookers is cooled down, and the enzyme glucoamylase is added to convert the liquefied starch into glucose or dextrose. For illustration reasons, the animation shown here is for a laboratory-scale distillation process. However, the full-sized process is similar. In general, the fermented mash, known as beer, contains about 15% ethanol and non-fermentable residues and yeast cells. The mash is then passed through a distillation column, where the ethanol is separated from the solid residues and the water. The ethanol comes out from the top at about 190 proof, and the unfermented residues, called stillage, are collected from the bottom of the column. The whole stillage is passed through a high-speed centrifuge, where the solids and liquids are separated. The solids, known as wet grains, are further dried, mixed with solubles known as distillers' dry grains with solubles, or DDGs, and sold as animal feed. Part of the centrate, known as thin stillage, is directly used in upstream processing. The ethanol obtained following distillation is passed through a molecular sieve where the remaining water is removed. The ethanol at this stage is called anhydrous ethanol and is about 200 proof. The pure ethanol is denatured with a small amount of gasoline, 5%. This is done at the ethanol plant. The ethanol is then shipped to various gas stations around the country to blend with gasoline to produce E10 or E15.